Hello friends, welcome to Electronic Circuit Hub. So today we are going to understand about three-phase half wave rectifier simulation in LTSpice. We are going to understand that how you're going to simulate the three-phase half wave rectifier in LTSpice. Okay. Then later I'm going to run the simulation and I'll show you the different input waveforms, the different AC waveforms at input side with the phase difference, and after that we're gonna see that what is your rectified DC output. Okay, so let us understand first how I have modeled the three-phase half wave rectifier. So if you look at the source here, I have the three voltage source, the V1, V2 and V3. And if I click on V3, if I right click on V3, so you can right click on V3, and if you look at here, the amplitude I'm using is 110. So the AC amplitude is 110 and the frequency is 60 hertz. And this is very important for three-phase simulation is what is your phase angle? What is your phase degree? So phase degree is 0. So this is my first source. So V1, V3 is my first source. And now let us go and look at the V1 source, the property of V1 source. So if you look at the property of V1 source, so I'll right click on here, and if you can see that the amplitude again I have 110 and the phase difference, our phase angle is 120 degree. So the phase angle is plus 120 degree. And finally, let's look at the property of V2. So if I right click here, so V2, if you look at again, the amplitude is 110, frequency is 60, and the phase angle is minus 120 degree. So that is how you can generate three-phase power source in LTSpice, because it's very important to understand how you're gonna create the three-phase power supply, a three-phase power source in LTSpice. So for the V3, I have the phase degree is 0. For V1, I do have the phase angle is 120. And for V2, I have the phase angle is minus 120 degree. So V1, V2 and V3 are the power source for your half wave rectifier. And if you look at now the D1, D2 and D3. So D1 is connected with V1 power source, D2 is connected with the V3 power source, and D3 is connected with the V2 power source. Okay, so these are, I'm using the diode here for rectification purpose. So D1, D2 and D3 are the rectifier diode which is connected with the power source of V1, V3 and the V2. And if you move ahead, I have the junction here wherein my cathode of each diode, cathode of D1, D2 and D3 are shorted together. Okay, so if you look at here, the cathode are shorted together, and we'll get here the rectified signal, and we'll get here the rectified signal, and then I have the capacitance 1000 microfarad, and I'm using a load which is 1000 ohm or 1 kilo ohm. So hope you understood how you can design the circuit in LTSpice for half wave rectifier. And let's run the simulation now and let's see how this circuit is going to behave. So in order to run the simulation, what you need to do is you have to go at simulate, edit simulation command, and you have to give the stop time. So what I'm doing here is the stop time for me is 100 millisecond. So you can also write the stop time is 100 millisecond, and I am running the transient analysis. So go at edit, and if you look at here, I have checked in the transient. So I'm running the transient analysis and the stop time is 100 millisecond. Okay, 100 millisecond. So now you can straight away run the simulation. So to run the simulation, you have to click on run button. Here we have the run button. So I'm going to click this button. So click on here, and you can also click run button from simulate, click on simulate, then run button. But it's better to use the shortcut for simulation. So I'm going to click here the run button, and let's see how the signal looks like. So let us first look at the input signal. So what is the V1? How let's look at one by one. So let me click on first V3, how the V3 looks like. Okay. So if you look at V3, it is starting from 0 volt and it has the peak value of 110 and it also has the negative peak. So you have G1 because you don't have any degree or phase difference. So it is starting from 0 and the amplitude is 110 volt peak. Now I'm gonna click the V1. Let's click on V1. And if I click on the V1, now if you look at V1 is starting 180, 120 degree out of phase with V3. So your V1 is 120 degree out of phase with V3 so that you see the green waveform is not starting with 0. It is starting with 120 degree phase shift. Now the last one V2, if I click on the V2, let's see. So if I click on the V2, V2 again is starting with the phase difference of minus 120 degree. So your V3 is 0, V1 is 120 degree and the V2 is minus 120 degree phase shift. That is how you can see I have generated the power source, three-phase power source for half wave rectifier. So this is the power source, and if I now click on the output, so if you look at here, if I click on the output, that is how it looks like. I see the peak voltage is having 110 or 19, so and it is having some ripple as well. Okay, 1.8. So I see around it is 1 to 2 volt of ripple, 1 to 2 volt at ripple at the rectified DC. Okay, at the output of your rectified DC. Now I have connected. If you look at here, the value of C1 is 1000 microfarad. Now what I'm gonna do is let us remove the C1 and let us see how your circuit looks like. So I'm gonna remove the C1 for now. I'm gonna remove the one net of the C1 and let's connect smaller net here and let's run the simulation one more time. Okay, so I have removed the simulation and I'm gonna run the simulation one more time. So you go and save it before running the simulation. So I save it. I'm gonna run the simulation one more time. Now if you are not getting the DC, you are getting some kind of this waveform which is having the maximum amplitude is 18 or 19 and the minimum amplitude is I see it's around 54 55 volt. So if you have not connected capacitor, your waveform looks like this. But if you have connected, let me connect the capacitor. So if you have the connected capacitor here and how your waveform looks like, it is, if you look at here, it is one kind of pure DC. It is one kind of pure DC, but it has some ripple voltage. So it has some ripple voltage which is around 1 volt. Okay. So guys, hope you understood how you're gonna simulate the half three phase, not single phase. It is a three phase half wave rectifier in LT-Spice. How you're gonna create the power source, how you're gonna connect diode and the filter component, that is the bulk capacitor. We call it as a bulk capacitor C1, and the output of half wave rectifier, we call it as a raw DC. So how you gonna see the raw DC, what happens if you remove the value of C1. So all the things, hope you understood. If you have any further question on this topic, feel free to ask me in comment section. Thanks for watching this video.